Determine if the series converges or diverges. We have 3/8 minus 3/13 plus 3/18, and so on. Notice we have an alternating series. Let's begin by writing sigma notation for the infinite series, which means we'll have to determine a formula that will generate the terms of the series. Notice the numerators are always 3, and the denominators are increasing by 5. 8 plus 5 is 13, 13 plus 5 is 18, 18 plus 5 is 23, and 23 plus 5 is 28, which means we can use a formula for an arithmetic sequence for the denominators. Recall for an arithmetic sequence, we have a sub n equals a sub 1 plus the quantity n minus 1 times the common difference d. In our case, a sub 1 is 8, and the common difference d is 5, which gives us a sub n equals 8 plus the quantity n minus 1 times 5. Simplifying, we have 8 plus 5n minus 5, which is 5n plus 3. So we have the sum, where the formula will have a numerator of 3 and a denominator of 5n plus 3, and n will start at 1 and approach infinity. And now we got to deal with the alternating sign. We'll have to include a factor of negative 1. If we include negative 1 to the power of n, though, notice when n is 1, the first term is negative 3/8, not positive 3/8. To fix this, we'll change the exponent to n plus 1. Now when n is 1, we have positive 3/8. When n is 2, we have negative 3/13, and so on. And now to apply the alternating series test, shown here on the right, we only consider the non-alternating part of the formula, or a sub n. The series converges if the limit as n approaches infinity of a sub n equals 0 and a sub n plus 1 is less than or equal to a sub n, meaning the terms from the non-alternating formula are decreasing. In our case, notice a sub n, the non-alternating part of the formula, is 3 divided by the quantity 5n plus 3. We'll first consider the limit as n approaches infinity of a sub n. Notice as n approaches infinity, the denominator increases without bound, the numerator stays at 3, and therefore the fractions get smaller and smaller and approach 0, which indicates the limit is equal to 0. So the first condition is met, and now we need to determine if a sub n plus 1 is less than or equal to a sub n. Using the formula for a sub n plus 1 is equal to 3 divided by the quantity 5 times the quantity n plus 1 plus 3, and of course a sub n is simply 3 divided by the quantity 5n plus 3. Simplifying the denominator on the left, we have 5n plus 5 plus 3, giving us 3 divided by the quantity 5n plus 8, less than or equal to 3 divided by the quantity 5n plus 3. When comparing two fractions with a positive numerator, the fraction with the larger denominator will always be less than the fraction with the larger denominator. In this case, notice 5n plus 8 is greater than 5n plus 3, which indicates 3 divided by 5n plus 8 will always be less than or equal to 3 divided by the quantity 5n plus 3. And therefore, a sub n plus 1 is always less than or equal to a sub n. Now we know the given series converges by the alternating series test. I hope you found this helpful.